So for the new information, I want to talk about correlation and regression here. And I'm going to be very directive about the teaching here as we kind of cover things. See if you can bring up the first page. Let's see. Emily, do you have the first page of this? Oh, there it is. It's just looking a little different. So on the first page of this notes, it has a sleep apnea example.
No, this is all one printing thing.
Yep, you're right. So
this is the first page.
there you go. You got it. So on the first page, it has a sleep apnea example. Do you guys know, Drew, do you know anything about sleep apnea?
A little bit. Yeah.
What do you know about
I
it?
just know it's a restriction of airflow when you're sleeping, and it causes you to not get a good night's sleep, and can cause you to not go into REM.
It can really be disruptive of sleep. It's actually a sleep disorder. Many times people do a lot of snoring because it interrupts the flow and you have more snoring episodes. So in this particular example, I decide, and Beverly, are you familiar with sleep apnea at all?
Yes.
So many times what has been reported, and if you look at the data set, what are the two variables that I'm actually talking about in this data set? Emily, what are the two variables that we actually have here?
BMI and snoring episodes.
So BMI, which is of course a way of measuring weight, the higher one's BMI, what does it look like is going on with this data set? Drew, what does it look like is happening for these 5 people as their BMI is higher? And I just arranged them that way. What does it look like is going on with their snoring episodes?
As the BMI increases, the snoring episodes increases.
Yes, so the real world statement just from eyeballing, which I'm very big on, as BMI increases for these 5 people, it looks like snoring episodes increase as well. Snoring episodes, very importantly, are considered maybe an operational definition of sleep apnea. You can consider snoring episodes an operational definition of sleep apnea. Because if somebody does more and more snoring, that's really a sign of sleep apnea. Remember, an operational definition is a mathematical way of defining something. The other important question I wanted to ask the 3 of you here is I wanted to ask you about the nature of these variables. And the question I want to ask you here is, are these variables continuous or categorical? So if you want to write that question down, are these 2 variables continuous or are they categorical? Any thoughts about that? Emily, any thoughts about that? Do you know what that question means or not really?
Are you recording?
I am recording right now. Are those 2 variables continuous or categorical? Drew, can I ask you that question?
I would guess, I'm not even sure. I guess continuous would be something connected with the other one. The 2 variables being somewhat connected.
So the 2 variables being connected, maybe being more continuous, it's the right answer, but it's not for that particular reason.
Okay.
Maybe I can even ask Beverly as well. Any thoughts, Beverly, on continuous versus categorical?
I think that they're continuous, but I'm not exactly sure why.
Yeah.
I know that they're not like in 2 separate categories. They're related.
Yes, that's very much the case. Think about all the other variables we've had this semester. Think about just the last example. We had group size. How many, what kind of variable was group size? Was group size continuous or categorical?
Continuous.
No, it was categorical. We had 2 levels. It was this or that.
So can you explain the
Sure.
definition?
A categorical variable is a variable that has specific categories. It's either this or that. Arousal, low, medium, high. It's specifically defined according to categories. Almost all the variables we've had all semester have been categorical variables, because they've been kind of preset and determined in this way. BMI.
So variables that have specific
Categories. That's right, specific categories. BMI can range all over the place. You can have any BMI conceivably out there. There are a lot of possible values. So BMI would be considered a continuous variable.
Continuous.
A lot of range, a whole lot of different values. You could have A BMI going, what, down to 15? Or if you're a gymnast, even less, up to 40, 50. I mean, it can range to a lot of values. Snoring episodes, same kind of thing. It could be 5, it could be 10, it could be 100. A lot of different values. So snoring episodes would be considered a continuous variable as well.
Oh.
So continuous variables are variables that can take on a lot of values. And when you have two continuous variables, it's very important to note, two continuous variables, the main statistic we can do on that is a correlation. Correlation is what you can do on that. Beverly, is that making sense for you?
Mhm.
So if you have two continuous variables, correlations are good. Let me even ask a little extension question
The
here.
best what you can do?
The best statistic you can do when you have two
Statistic.
continuous variables are correlations. Let us say, and if you want to write this other example down, let us say that you're the owner or you're thinking of opening up a new Dairy Queen. Beverly, do you do Dairy Queen?
We have one right near our house.
Okay. Drew?
Yeah, so say it's about 2 miles away.
And I don't want to tell the answer for Miss Emily because I have insider information. Yes. So let's say you were thinking of opening a new Dairy Queen somewhere around the country. Would it be good to collect some data on which stores have the most sales? Would that be a good thing to do? It probably would. Let's just say, for the example, that we measured in 5 places the temperature and the sales of ice cream cones. Temperature and sales. So we found a Dairy Queen in Hawaii. No, I'm sorry, a Dairy Queen in Alaska. Emily, what would be the daily temperature in Alaska?
Well, in the summertime or the winter?
So we're saying for the whole year, we're collecting what the temperature is and what the sales are. So the average temperature in Alaska during the course of the year might be what?
32.
32 degrees.
It is not like that in the summertime.
But average through the year.
I'm going to Alaska in the summertime, and it's not going to be 32 degrees.
You want to get out of here by 8 though. So 32 degrees. So let's say it was 32 degrees.
In the summertime.
So the temp, what would be, no, average the year round, 32, sales. Let's pick a number. Maybe, I don't know, how many ice cream cones? Maybe, let's say, 1 million. Okay,
so
let's
it's obviously continuous.
continuous, two continuous variables. Let's go next to another state. Let's take North Dakota. Beverly, what have you got for temperature there? Don't do 32. What are we thinking here?
Maybe 45.
45. Okay, we had 1 million before. Drew, what would you like now?
1.5.
Okay, 1.5 mil. Next, we go to, what would be good next? Missouri.
What are the initials for Missouri? MI?
M-O.
Yeah,
MI
you're
is
right.
Michigan.
No, you're right. I was going to say, wait a second.
Missouri.
I was not in math.
Actually, I like Michigan better next. Michigan.
Oh, okay.
Actually, even better than Michigan. Don't do Michigan. I'm a Buckeye. So what state am I from, Em?
OH.
O-H. I-O. So Ohio, average temperature for the year, let's do 65 degrees. How about 2 million? Next, let's go Georgia. What, 80 degrees?
What are the initials for Georgia?
GA. Georgia, GA. How about 5 million? And then finally, Florida. 90 degrees. How about 10 million? What kind of statistic would be appropriate to run there? Beverly, what kind of statistic would be appropriate here?
A correlation.
A correlation. That's exactly correct, because these are continuous variables, two of them. We run a Pearson product correlation. And we're going to go back now to the example that we have on the screen here. One thing that we can actually do, and you actually have it on the handout, you can actually make a little scatter plot. You can see I kind of did that there with, which example was this? This was BMI and snoring episodes. And if you make a little scatter plot up, it looks like, Emily, what does it look like is happening in this picture? As BMI increases, what does it look like is happening to snoring episodes?
They increase.
Yeah, it looks like
So
there's
it's
an...
a positive correlation.
It's a positive correlation. Let's go over what correlations can range from. What's the highest value? Drew, can I ask you, do you know what the values of correlations can be?
Is it -1 to 1?
That's exactly the case. Correlations can range from -1 to +1. This would be an example, and actually, I did it out on SPSS. I should have probably shown you how to create that. Actually, we may pause for a second, I think, here. It is really simple to do. Let me stop the tape here. Actually, maybe we'll even talk over the tape. Yeah, let's actually go into SPSS and create it. Emily, can you see if you can, I don't know, you got the screen here. Let's actually create, Beverly, are you able to create things here?
Yes.
So let's create two variables. Emily, what two variables do you need to create here? What are the two variables for this
BMI
problem?
and snoring.
There you go. Just make one BMI. Go ahead. It's right there. Just type in BMI. And then do enter. And snoring. And then go back to the, there you go, snoring. That's good. Don't fall asleep on me, Em. And enter.
I hate snoring. Oops.
Write the word snoring.
I did.
Not quite right yet. And enter. Okay, now go back to the data view. And Drew, do you want to read to her what she would put in here?
Sure. For BMI, you've got 30, 32, 35, 38, and 40.
Okay.
For snoring,
Go up to snoring. There you go. Go ahead.
you have 10, 15, 25, 40, and 80.
And 80. Okay, Beverly, have you got yours as well?
Yes.
Okay, so Beverly, do you know what you would do next here to run the correlation?
You have to go to analyze.
That's right, so go to Analyze. Emily as well. Guess which one you're going to choose, Em?
Correlate.
Correlate. Bivariate, correlate. There you go. And guess what you put in there?
BMI and snoring.
There you go. It's not rocket science. And do, okay, boy, have you guys ever done a correlation out by hand? It really sucks. Oh wait, I got that on tape. It's not much fun to do by hand. Beverly?
It shows this. It doesn't show that thing.
It doesn't show the screen. I actually made my own scatter plot, but does it show what's on the next page? Woohoo! I must have done it right. So what kind of correlation is that? It's 0.91, 0.915. Beverly, is that good news or bad news for us?
Bad news.
Bad news. Why do you say bad news?
Because it's greater than 0.05.
Well, that's the correlation. The correlation is
Oh,
0.91.
okay.
What's the sig
okay.
value? Emily, what's the significance value?
0.029, so it is significant.
Yeah, this is it was a good point, Beverly. We want a very large correlation up to +1. We hope for a large correlation, and then we look at the line for sig to see if it is statistically significant. So 0.91 is very large. And that's good news for us. It is statistically significant. How would you write it out in APA format? Drew, any thoughts about
I
that?
don't remember the symbol for correlation, but I
This-
know it's, is it R?
Yeah, R. You write little r, and then in parentheses,
Degrees, no, it's just,
yeah, it's degrees of freedom in the parentheses.
okay.
The question
Yeah,
is,
calculate that.
how do you calculate that?
Would it be categories minus 1 again, or is it?
Yeah, sometimes categories, but for correlations, it's always 2 categories, so it can't
Oh.
quite be that. Good guess. Emily, any thoughts? What is it usually?
It's usually DF.
The DF, but usually it's related to N in a way. What do we usually do for anything in ANOVAs? We said how many, and then what did we do with the how many?
We subtracted 1.
Yeah, we subtracted 1, so you might think it might be 5 minus 1, right? The N minus 1. But it turns out that a correlation is based on a straight line, and for a straight line, you always have to have 2 points. So for a correlation, and you want to write this for your notes, it's always N minus 2. It's N minus 2. So what would it be in this case? Beverly, what would it be in this case?
3.
It would be R, and then in parentheses, 3. And then it would be what? Equals?
0.029.
Not quite. Not. First you have to write the correlation. 0.915, and then P equals 0.029. This is statistically significant. Boy, there's some very interesting clouds outside. They don't look too good there, Miss Beverly. I hope they're not coming to Stewart's draft. What do you think, Drew?
This
I'm
doesn't
not
look
sure
too
which direction that is,
terrible.
actually.
What's that?
I'm not sure which direction that is.
Yeah, it's probably going to funnel in this way. All right, well, we'll keep going with it. So anyway, this is a positive correlation. What would be our real-world statement here? Drew, what would be the real-world statement?
As your BMI increases, your snoring episodes or sleep apnea
Increases as well. As your BMI increases, the heavier you weigh, the more snoring episodes, the apnea is going to increase. So you always
How
write
is
your
the
real-world.
N5?
Because how many people do we have here, Emily? How many people?
Oh, I get it.
So we have 5 people in our sample. They each gave us 2 data points, or 5 examples here. So that's positive. Is it any better? Well, let's say I ran a correlation and I got negative 0.91. Would that be better or worse than this? Negative, if you want to write it out for the notes. Let's say I ran another study. Let's say I ran a study and I was looking at the relationship between temperatures and number of parkas purchased. Temperatures and number of parkas or minks purchased. And let's say the correlation was 0.915, negative. What would that say? What would be the real world behind that?
As temperature goes up, parkas sales go down.
Yeah, as temperature goes up, parka sales go down, or as temperatures go down, parka sales go up. It's negative, so if it's negative, it just says it's opposite, but the number is the strength. And they would be equal relationships, equally as strong. What would be a bad correlation is kind of the last point here.
0.
A correlation close to 0 says there's really no relationship between the variables. So a correlation near 0. All right, I think I'm going to cut the recording off here and then continue on.